Welcome to the last lesson of week 2 of AP Calculus. We're going to be looking at derivatives, as I talked about a little bit in the last lesson. As a reminder, everything is due by the end of the day on Friday, so if you're a little bit ahead, awesome. If you're a little behind, just make sure you're getting all your presentations, your check-ins, and then, of course, your quiz done for the week. So we're going to talk about the derivatives of polynomials and exponential functions, starting in Chapter 3, Section 1. So make sure you've got your notes materials ready to go, and let's get started. So the first one, we're going to look at polynomials, and we're going to talk about the power rule, which means that the derivative, so d dx, of x to the nth power, a lot of us think about this as the n comes down in front and minus 1, and you end up with nx to the n minus 1 as the derivative. So when we're differentiating, I started us off with a weird one because that's good for you. F of x is equal to the cube root of x squared minus x root x. So the first thing we want to do is write it in terms of an x to an exponent. Now, of course, you could use the product rule or the chain rule or anything like that, but I think that this is just significantly easier. Remember, if you've got a root, that means the exponent is a fraction. So a cubed root is 1 over 3, a square root would be 1 over 2, etc. And this would just have an x squared still with it. So that first term becomes x to the 2/3, multiplying those exponents together. The second term, as we said, the square root becomes x to the 1/2, and then with multiplication we add them, so then this becomes x to the 1.5 if you want to write it in decimals or fractions, either way. Same rule is going to apply for both. Take the exponent, make it into the coefficient, minus 1, exponent into the coefficient, minus 1, and we end up with 2/3 x to the negative 1/3 minus 1.5 x to the negative 0.5 if we're using decimals. You can leave it like that, or you can simplify however you like. I'm going to leave it like this as our answer for f prime of x. Now, a more complicated question would be find all the points on the curve y equals x to the 4th minus 6x squared plus 4 where the tangent line is horizontal. So this is a nice reminder of some facts that we want to remember about our first derivatives. And that first one is that tangent line and its slope is equal to our derivative. This is another place that I think the Leibniz notation is helpful because we're talking about slope of a line is the change in y over the change in x. So y2 minus y1 over x2 minus x1. And we're talking about an instantaneous one for the tangent as it grazes past the graph. So what we see here is that if our slope is horizontal, the slope of a horizontal line is 0, is equal to our derivative. So that's basically what this is asking here. So here, we're going to set 0 equal to the derivative. We're going to do the same thing here, taking the derivative. Take the 4, turn it into the coefficient, minus 1, so 4x cubed. Here, 2 comes in front with the 6. And the 6, as if you remember, the constants just stay there. So this becomes 6 times 2, x to the 1st. And then if you remember, the constants at the end without any terms just disappear. So 2 more quick rules. So if you don't remember those from last year, you can copy those down. Pause when you need to. I'm going to simplify. 0 is equal to 4x cubed minus 12x. And now you can just solve it like a polynomial. I'm going to factor out the greatest coefficient, which is 4x times x squared minus 3. So then the solution for that first factor, 0 is equal to 4x, so x equals 0. And for the second one, it would be plus or minus root 3. So these are all the x values. If it asked for the points, we're looking for a coordinate pair x, y. If we plug in 0 there, we end up with 0 for our x and then 4. If we plug in positive root 3, that will give us 9 minus 6 times 3 plus 4, which is negative 5, which would be the same for the negative root 3, negative 5. So those are the 3 points where the tangent of that graph is horizontal. Now, we can have exponents where the base is x and the power is the number. We also can have ones where x is the exponent, and there's two rules. One where it's e to the x, and this one's one that I generally have students always remember. The derivative of e to the x is just e to the x. Now, you also might have it just be another base a. The derivative of a to the x is equal to a to the x, but then times the natural log of a. If you're interested in why this is true, there's a proof in the guided notes that are attached to this assignment. I'm going to keep going because I don't want this video to get too long. So here it says, when is the tangent of y equals 2 to the x parallel to y is equal to 2x? So again, parallel means that they have the same slope. So that means the question is, when is the derivative of 2x here equal to the derivative of 2 to the x? Now the second one is a much easier derivative to take. That's just 2. Now, and here we're going to use our second formula with our base a. So that's going to be the ln of 2 times 2 to the x. And you're definitely going to want a calculator to solve this. We're going to start by dividing each side by the natural log of 2. And we end up with 2 to the x is equal to 2 over ln of 2. From there, I'm going to take the natural log of both sides, since I do not necessarily have a calculator that will do different bases. And when I do that, the exponent gets to jump in front. So I have x times ln of 2 on this side is equal to the natural log of 2 over ln of 2. When I divide both sides by the ln of 2 here, I would just recommend to type this into your calculator. You could leave your final answer as ln of 2 over ln of 2 all over ln of 2, which seems very complicated, which might be the answer in the back of the book. You also can see that x is approximately equal to, on your calculator, 1.529. And you're going to go to 3 decimal places in this class. That's what the AP will always expect of you on free response. So have an absolutely wonderful day. Leave questions in the comments. You can get an appointment, or you can send me an email. I'll talk to you later.